subject we're going to deal with today is pathfinding. Pathfinding, for those who are not exactly sure what it is basically finding a path from one point to another inside a map or an area, just to make it clear. A route, preferably, and the shortest one if possible, of course. Pathfinding is actually interesting for Castle Story because there are a lot of nested, you could say, challenges, one inside another, that makes it a bit different from usual pathfinding problems we encounter. So I'll go through the different challenges, but I still want to mention, yes, there are some, you could say, technology is not the right word, but techniques or data models for pathfinding, like nav meshes and A-star, stuff you might have heard. I'll explain as to why they're not exactly perfect for Castle Story, by the way, throughout the this video here. In between the challenges, I'll explain in a second. So the first real challenge we've got is that our levels are not necessarily created at our studio. By that I mean it's usually, data maps that could be created via world editor. That's something we really want. So we cannot just simply bake our navigation data inside our studio, right? Just be done with it, ship it, and there we go. Navigation data is ready. That's not really possible. So we cannot calculate it inside the studio, pre-calculated during our build of our game. Okay, first challenge that is pretty important, and it leads us to the second one. We could just simply do it during loading instead? But then again, that doesn't really work because our environment is highly destructible and constructible. It's the core of our gameplay, being able to actually block characters. So we need to be able to update this pathing data on the fly in game all the time. So that pretty much rules out the whole concept of what I mentioned earlier, nav meshes, and I'll show you a quick picture here. It's this one here. So this is what we call a nav mesh. It's like a 3D model, you could say, of the walkable area. You see all those triangles here? That's the path it's following. We can't really use that simply because it's actually quite expensive to produce with a voxel world like we have, because it's changing so much. So it's not really efficient. So we're stuck not using nav meshes in the end. So what do? Well, we actually use algorithms that use more grid algorithms pathfinding. And by that I mean A-star, like I mentioned earlier, is a form of grid pathfinding. I'll come back to A-star, no worries, okay? Just to give you a quick picture. But point is, in our game, when you see, I'll just show you a quick picture of the game. This is Big Island. You guys can't probably see the scale, but this is 1,000 voxels per 1,000 voxels. So we have millions of nodes to process. It is huge, huge, huge. So we need an efficient way to actually process all those nodes when we want to find a pass through here. So plain A-star is actually pretty rough for that because there's so much data to process, and I'll give you again a quick example in a matter of seconds. But the fourth challenge that leads us to is the biggest questions in our game, which is currently the one that's causing a lot of issues, and we're trying to solve. Question is there a path? Is there a path, you could say, like yes or no? Can I go there? And to understand why it's complicated, I just want to show you a quick video of pathfinding, just to give you an example. And meanwhile, before I show you this here, I'll just start a regular pathfinding. So we're going to start from here to here, and I'm going to use regular A-star, like I mentioned earlier. I'll show you also at the same time what is A-star. So I'm just going to, 430, it's calculating. Oops, give me a second. I'll use it like this. So it's going to calculate a path, meanwhile, in the background. We'll come back to it later. So what is A-star? See, let's say this is a grid. A bit like our voxel world we picture, right? But it's just 2D, which makes it simpler than in our case. A lot simpler, actually. But you'll get the picture. So we want to get from the green little dot here to the red dot here. So how does this happen? Well, we'll use our A-star and say, just find me a path. So as you can see, the blue area is the way it's actually looking. This is kind of the eyes of the computer, where it's actually looking for a path because it can't see everything at the same time. And you notice here, it found a path pretty easily. It took 1,500 square analysis, you could say, all those voxels or grids, whatever, to find a path. Okay, this is good. But remember the question was, is there a path or not? What happens if there's no path? Well, a lot of you probably guessed it, but what's going to happen is that for it to be sure there is no path, it actually needs to see the whole grid at the moment with A*. So this is a problem. Remember how in games sometimes the character is stuck and just waiting to figure out if there's a path to go? Like this, as you can see, is huge. We filled everything and it took us almost 4,000 blocks. This is a 50 by 35 voxel. It's a pretty small grid. And it's 4,000 nodes it needed to evaluate to make sure there is no path. So let's picture a situation game. Here we have our little character here. Oops, sorry for the pause. We have our character here. So if you look at it clearly, there's no direct, it's actually right next to the block. It's pretty close in theory, but in practice, you need to walk, it needs to find a whole way all through there, which is really long. And that probably results in like what? Maybe 10,000, 12,000 voxels to be analyzed. It's huge. So this question is actually quite big. Is there a path or is there no path? Answering it really fast would solve a lot of issues, so you can just go deeper, right? That's the core of the challenge for Castle Story, actually. So let's go back to our little demo here, where we used A* in one of our on Big Island, which is 1,000 by 1,000. So starting from here to go through here, it needed to scan what is 300,000 blocks. 320,000 actually blocks. 320,000 voxels needed to be scanned before it reached there. So this is huge. So why are we making this video is that one of our devs here, Benoit Alain, some of you might remember, he did the voxel engine, also the huge voxel engine in the GPU, figure out a way actually to probably do this a bit faster. And I want to show you a quick demo on how the reliability really went up with his technique. So let's see, we're going to use this one here. It's this. So see, actually, instead of taking 15 seconds, it took us, wait, well, it says 0. So this is actually really fast. Well, instead of searching 320,000 squares, we said it searched for 62 squares. You can see all the path here it made. 62 versus 300,000. This is like a scale of almost 5,000 difference. This is just huge. So just getting to know, is there a path to go there? Literally cost us no time. This was a huge advancement. It's actually pretty fun. As you can see, there's some kind of a hierarchy thing done for pathfinding. I won't go into details today, but that just gives you a quick overview of how it can really help analyzing the paths for the whole game. And yeah, that's about it. So in the next video, what we'll explain to you is actually more the intricate details of what's going, how come it's so fast, the different challenges we've encountered actually with this technique. But for now, I just wanted to show you the really nice advantages this new technique provided us with all these fast analysis for paths.